What's up, guys? Today I'm going to be talking about the Big Freeze theory. The Big Freeze, also known as the heat death, is one of the possible scenarios predicted by scientists in which the universe may end. It is a direct co-sequence of the ever-expanding universe. The most telling evidences, such as those that indicate the increasing rate of expansion in regions farthest from us, support this theory. As such, it is the most widely accepted model pertaining to our universe's ultimate fate. The term heat death comes from the idea that an isolated universe, the universe being a very big example, the entropy will continuously increase until it reaches a maximum value. The moment that happens, heat in the system will be evenly distributed, allowing no room for usable energy or heat to exist, hence the term heat death. That means mechanical motion within the system will no longer be possible. Observations suggest that the expansion of the universe will continue forever. If so, the universe will cool as it expands, eventually becoming too cold to sustain life. For this reason, this future scenario is popularly called the Big Freeze. Out of respect for the law, specifically the second law of thermodynamics, which tells us that total entropy, basically chaos, in the order of the universe always increases. The second law of thermodynamics is one of the supreme laws in all of physics. If a scientist proposes a theory that violates it, he's in big trouble. Entropy is unique because it's the only quantity in the physical sciences that indicates a particular direction for time, the arrow of time. It tells us that there is no hitting a rewind button to the beginning of the universe. Chaos and disorder doesn't suggest a particularly violent end, rather than a big chill. While entropy doesn't necessarily refer to dramatic destruction. It's more about how stuff just tends to fall apart. Think about food sitting on your kitchen counter or in the refrigerator for an extended period of time. It will eventually rot, or in your car, which will begin to rust, decreasing its original strength. This example you're most familiar with is the way your body undergoes decline as it ages. Your vision and hearing gets worse, you're not as strong as you used to be, your hair thins, you start to see wrinkles, and eventually your body proceeds to shut down. So the galaxies of the universe will eventually disintegrate. Dead dwarf stars will drift away into the darkness along with halts of neutron stars, and everywhere there will be black holes. There are an estimated 76 trillion stars in the visible universe, organized in billions upon billions of galaxies. To put things into perspective, that's 70,000 million, or 7 followed by 22 zeros, and about 10 times as many stars as grains of sand on all the world's beaches and deserts, a number so large it's impossible for us to even imagine. Right now we are in the stelliferous age of the universe, the period in the life of the universe when there are still stars. Yet the entire age of the universe is taken into consideration. It turns out that stars burn brightly only for a short period of time. A trillion years from today, almost all the stars will have burned up their nuclear fuel. A trillion years after that, even the black holes will have disintegrated. After that, even the protons themselves will begin to decay. The universe will then become a freezing mist of electrons and eventually approach absolute zero. At this point, all motion stops, and that's the Big Freeze. Now, this kind of ending is a stark contrast to what other scientists believe will be the universe's ultimate fate, known as the Big Crunch. The Big Crunch, if it does happen, will be characterized by the collapse of unimaginably gargantuan portions and will even culminate into an immensely massive black hole. The Big Freeze, on the other hand, will happen less fanfare since everything will wind down to a cold, silent halt. To determine which ending is most possible, scientists need to gather data regarding the density, composition, and even the shape of the universe. For example, if the density is found to be lower than what is known as the critical density, then continuous expansion will ensue. If the density is equal to the critical density, then the universe will expand forever but at a decreasing rate. Finally, if the density is found to be greater than the critical density, then the universe will eventually stop expanding and then collapse. It is therefore clear, for a Big Freeze to occur, the density must be less than the critical density. Accurate measurements made by the WMAP, which picks up cosmic microwave background radiation, indicate that a density is much less than the critical density. This is very consistent with observations at the outer regions of the universe, that being increasing outward velocities of galaxies as they are further from us. Through these observations, as well as density measurements, more scientists are inclined to believe that the most possible ending is that of a Big Freeze. If dark energy, represented by the cosmological constant, a constant energy density filling space scalar fields such as quintessent or moduli, dynamic quantities whose energy density can vary in time and space, accelerates the expansion of the universe, then the space between clusters of galaxies will grow at an increasing rate. Redshift will stretch ancient incoming photons, even gamma rays, to undetectably long wavelengths and low energy. Stars are expected to form normally from 1 to 100 trillion years, but eventually the supply of gas for star formation will be exhausted. And as existing stars run out of fuel and cease to shine, the universe will slowly and inexorably grow darker, one star at a time. According to theories that predict proton decay, the stellar remnants left behind will disappear, leaving only black holes, which themselves will eventually disappear as they emit Hawking radiation. Ultimately, if the universe reaches a state in which the temperature approaches a uniform value, no further work will be possible, resulting in the final heat death or freeze of the universe. Alright guys, that about wraps it up for the Big Freeze theory. If you enjoyed this video, a like would be appreciated, and subscribe for more content like this. See ya.